Hi, welcome to our presentation of a melting point determination in the chemistry lab. It is the thermal analysis most used to characterize solid crystalline materials.
It helps us to identify unknown substances and to know whether a substance is pure or not.
If a substance contains moisture or some other impurity, the melting point is lowered. A sharp melting point indicates it is pure.
The force of attraction between the particles are at different places, hence it melts at constant temperature.
Impurity lowers the melting point of a solid.
In our findings we used a melting point apparatus.
It is a scientific instrument to determine the melting point of a substance.
Insert the tube's open end into a pile of the solid to be studied.
If the substance is granular, it should be pulverized before packaging.
To get the solid to fall to the closed end, invert the capillary tube and lightly tap at the countertop.
Drop the capillary tube closed side down numerous times. When the capillary tube strikes the tabletop, it bounces and packs the solid into the tube's bottom.
If the solid isn't packed tightly enough, it will shrink when heated, causing misunderstanding about the proper melting temperature.
Repeat the preceding steps to load the sample until it reaches a height of 2 to 3 mm in the tube if necessary. The sample must be no more than 3 mm.
In melting point equipment, place the capillary tube carrying the sample in a slot behind the viewfinder. Each apparatus normally has 3 slots, and after you've mastered the
turn on the equipment and adjust the heating rate to the desired level. The rate of heating is frequently experimental, and it should be fine-tuned by keeping a close eye on
image a magnified view of the sample in the apparatus, which should be lighted through the viewfinder.
If the estimated melting point of the compound is known, heat the compound at a medium pace to 20 oC below the expected melting point, then reduce the rate of heating to no more than 1.
As the melting point approaches, the temperature must be gradually increased in order for the system to attain equilibrium, making the thermometer temperature an accurate gauge of the solid's true temperature.
If the compound's expected melting point is unknown, heat the sample at a medium rate for the duration of the experiment to determine an estimated melting point.
Assessment of the melting point.
For a second melting point test, a new sample is required. Even if the previous sample solidifies after cooling, it should not be used again. Different melting ranges could result.
If the solid begins to pull away from the tube's walls to create a cone of solid, this indicates that it is approaching its melting point. Melting will usually take place
with the arrival of the first visible drop of liquid. Record the first temperature of the melting range. When a droplet is detected on the side or bottom of the tube, it may appear as if the surface
movement will be noticed in the tube. Take a temperature reading and round it up to the nearest degree. Despite the fact that certain thermometers read with better precision, the imperfect heat
when the entire sample has just melted, which occurs when all areas of the opaque solid have transformed to a transparent liquid, record the second temperature of the melting range.
During the process, the following uncommon scenarios may arise. Before the sample melts, it may begin to discolor, indicating that decomposition is taking place.
Decomposition is indicated by the letter D following a melting point. Instead of melting, the sample may sublime. A ring of solid above.
If a second melting point trial is to be conducted immediately after the first, the metal block should be rapidly cooled to at least 20 degrees Celsius below the next melting point.